group paid loss, and here's our Project 3 priority presentation. So here's a record of our running demo because the actual run is kind of long, so we just recorded that. Try to make it short, to fit 3 minutes. So we run SC360N, and then we run SC300N to push these two process into the list. And we run PS-L. As you can see, we have output the priority of each. Like you see 17 and 18, that's a SC360 300, and then we run renice-N217. So as you can see now, the processor on the 17 ID changed priority to 2, and now it's priority lower than the processor on the 18, which is 360, and then this 360 is supposed to finish first because it has priority now and it's actually running. And here's the waiting part, it's pretty long, so I just skip. And here, as you can see, the one above we have 19 process ID, right? And then the one below we have 18. The one that actually finishes the one on 18, which is SC360. So it finished first, and then now the SC300 is running right now on the 17 with priority 2. And now it's supposed to finish sometimes later, but yeah, that's pretty much it. Now here's our code. Here's the really nice part.
So my name's Ciara Magical, and I worked on the Renice file. So for the Renice file, it basically works similar to the Ubuntu Renice command. So it just alters the priority of a process. So first in the execution function, it's going to get the arguments, which will be the PID, which is the process ID. And then it's going to also get the priority, which is which priority level you want the process to run at. And then after a result, it's going to go into the process client to run the process info function. And then after, it's going to check to see if the process exists. So if it does not exist, it's going to return a invalid argument, which is going to say no process of ID is found. And then it's going to check also check the new priority is valid. So if the priority is greater than 5 or less than 1, it's going to return an invalid argument. And it's going to run the renice PID function, which actually changes the process to that priority and also print out that the process is set to a certain priority. And that's pretty much it for this part.
So my name is Nishaba. Second part is schedule CPP, and then first of all, I'm gonna check the NQ. So it check the process if in the ready state. If not in the ready state, gonna throw the error on line 42. If it's ready state, it's gonna put into the queue. And after that, we're gonna do the DQ part. So the same, we're gonna check if it's ready. If it's ready, then throw the error on 54, and then if not, then check the queue. If that PID is not in the queue, then throw the error again in like 71, and then else the DQ that PID from the queue.
Okay, so now this is the PS part, process list. So we modified it we pretty much just add the -L flag here, which is the flag that we're looking for a priority. And we just add a couple of things in the main function. But if we have a -L flags, then we know that we're looking for a priority, so we add a priority column right here. If it's just PS, then it's just a normal print right there. And then for here, for this part, if we're looking for a priority, we're gonna also output the priority state of each PID. And that's pretty much it for the process list part. And for the code, Sarah did working on the renice. Mel did work on the scheduler, and I pretty much modified the PS part. So for the challenges, we have a couple of challenges because we don't know about this at all, and we try to look up documents and Google a lot of stuff basically. And so anything we learn, I think we learned how the command line works, like from backends parts, I guess. And that's pretty much it for our presentation. Thank you.